Hello, welcome to section 10.3, area of a parallelogram. The area of a parallelogram correlates to the area of a rectangle because a rectangle is a parallelogram, meaning that its opposite sides are congruent. But the formula for area of a parallelogram is a little bit more complicated just because we're not used to using this formula like we are a rectangle. So the area of a parallelogram is found by taking base times height. A couple things to remember. Base can be any one of the sides, so it does not matter which one is the base. But the height, this is the important part. The height is the distance from the base to the opposite side. Okay, it must form a right angle with the base. So you're looking for the altitude that's being dropped down. So this line that's being dropped down that forms a 90-degree angle with the base. So looking at your problems tonight, when you see your right angle, that's going to tell you, first of all, what the height is. Okay, this is my height. And what the base would have to be that you're going to have to use, because you cannot use the base that does not have a height that corresponds with it. Okay, so once again, your height is going to form a 90-degree angle with your base. Okay, and it's going to usually drop straight down. The only, well, with a rectangle, that's why we have length times width, because the height and the base form, or the length and the width form a 90-degree angle. So that's what makes it a little bit different. You're using the same formula, but we call it base and height for parallelogram because the length and the width would not necessarily be what you're using within the formula. Okay, so here's our first parallelogram right here. You'll notice that my 90 degrees is on the outside of the parallelogram, but still nonetheless, it's being dropped from one base to the other. This is going to be my height. The base then, once again, is what's being formed from that 90-degree angle. That 90-degree angle is actually meeting with this side, which is 4 meters. So this is my base. So in this problem, the 17 meters is not going to be used because it is not what is forming or forming that 90-degree angle. Okay, it's got to be the two sections forming the 90-degree angle. That would be the base and the height. So my formula will be 16 times 4. Base times height. Actually, I have that backwards, don't I? It doesn't matter, though, what order you put it in because multiplication is commutative, meaning it doesn't matter in what order you're multiplying these. Okay, so 4 times 6 is 24. Carry your 2. 4 times 1 plus 2 is 64. And because its area is going to be meters squared. Okay, remember area is measuring the distance inside of the figure. So if it's measuring the distance inside the figure, I want to know how many square meters, okay, is present within the parallelogram. So 64 meters squared. Okay, our next one is just given to us on a grid. A lot of times on the grid, you're just going to have to count, and actually I think this is one of those, but the grid gets moved. So let's pop these back up here real quick. Here we go. Okay, so you actually would count the units. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's count again. 1, you're counting the squares. 1, 2, 3, 4, 5, 6. Pen's not working. 7, 8, 9, 10, 11. So I'm going to change this to 11 units. Okay, and then I'm going to count the height. And once again, the base and the height, you're looking for what forms that 90-degree angle. And I have 1, 2, 3, 4, 5, 6, and 7. So it's going to be 7 units, not 8, to form the height. Okay, within a parallelogram, once again, you have to make sure it's 90 degrees. So if this is dropped straight down from any one of these, it's going to be 7 units. So it doesn't matter which one's dropped down from it. You're looking for that 90-degree angle. Okay, so the area is base times height. My base is 11. My height is 7. So 11 times 7 is 77. And I do not have centimeters or inches. It's just units. units squared. Okay, it still has to be square units. And actually you can see all the little squares that this is made up of when you look at it on a grid like this. Okay. Now we're going to find the area of the shaded region. When you're doing this, I want just the area of the green part. So I have this big rectangle here. Okay, and inside that rectangle is a parallelogram. So if I find the area of the big rectangle, what I need to do is take out the area of the parallelogram to find the area of the shaded part. Okay, so I'm going to find the area of rectangle. And then I also need to find the area of the parallelogram. Okay, so when I look at my rectangle, I have a base and a height, or a length and a width, that is going to be 25 times 11. Okay, remember in a rectangle, the base and the height are the length and the width because they form 90 degrees. So 25 times 11 is 275 feet squared. Now I'm going to find the area of the parallelogram. Well, here's my 90-degree angle. So this is my height, and this is my base. So the area is going to be 12 times 4, which is 48 feet squared. Okay, so what I'm going to do is I'm going to take the area of the rectangle and I'm going to subtract the area of the parallelogram because I'm taking this part out. It's like the donut hole, the middle of the donut. I have to take that out. That's not part of the area. I don't get to eat it. Okay, so we take that out of our area. So I have 275 minus 48, and you get 227 when you subtract. Okay, it's still an area, so I need to put my feet squared on there, and that would be the answer. Okay, so once again, very, very important that you know that tonight you're looking for the base and the height. Okay, they have to form a 90-degree angle. It's extremely important. All right, anything extra that they give you is not important information. Like here, the 17 meters is not important information. So don't just immediately look at the two numbers you're supposed to multiply together and apply those, because that does not always work like that. Okay? As always, if you have any questions, make sure you ask Mr. Coolinger or myself so we can go over them with you. And as always, thanks for watching.